Okay, I just wanted to do a quick demonstration of balancing chemical equations. So I am on page 249 of the textbook. So if you want to, you can open up and follow along with me. I'm going to go through just a couple of problems. First, I'm going to do number 27. The reason that we balance equations is because chemical reactions need to obey the law of conservation of mass, which says that nothing can be created or destroyed in a reaction. Right now, this equation is not obeying that law because I have two oxygen atoms right here and only one right here. And I can't have an oxygen atom just be destroyed in this reaction. So this needs to be balanced. Now what you can do to keep track while you're balancing an equation of how many of each element you have is make a table like this. The left side represents the reactant side, or the left side of the equation. The right side represents the product side. So I'm going to write down each element that I have on the reactant side and those same elements on the product side, because I'm going to have them both before and after the reaction happens. Then I'm going to count how many of each I have. So I have 1 copper, 2 oxygen on this side. On the product side, I have just 1 copper and 1 oxygen. In order to balance my oxygen, this needs to become a 2. Now the only way that I can balance this, that I can make this become a 2, is to add coefficients. I cannot change the subscripts. Okay, the subscripts are these little numbers right here. I can't put numbers in the middle of a molecule or formula unit. I can only add coefficients, which are numbers in front of the molecules or formula units. So, in order to make this oxygen become a 2, I'm going to add a 2 right here. Now this 2 affects both the copper and the oxygen. So now I have 2 coppers, so I'm going to change the 1 to a 2, and 2 oxygens. So now my oxygens are balanced, but my copper, my Cu, are not balanced. I have 2 on this side, 1 on this side. That's easy to fix. I can just put a little 2 in front of there. And that makes me have 2 coppers. So now this equation is balanced. Now I want to show you 1 or 2 more. So I'm going to go down to number 31 right here. It's a little bit more challenging. So number 31, I'm going to draw the chart again. I have As, which is arsenic. I have chlorine, hydrogen, and sulfur. And then I'm going to write those in the same order. It's a lot easier if you write these in the same order on each side of the table, because then it's easier to compare what you have. On this side I have 1 arsenic, 3 chlorine, 2 hydrogen, there's a 2 right there, and 1 sulfur. On this side I have 2 arsenic, 1 chlorine, 1 hydrogen, and 3 sulfur. So the first thing I'm looking at is arsenic. I only have 1 on this side, I have 2 on this side. To balance that, I'm going to put a 2 right here. That gives me 2 arsenic on this side. Now this chlorine was 3. The way this works is the coefficient multiplies by the subscript. So instead of 3 chlorines, I now have 6. 2 times 3 is 6. So I'm going to change that to 6. Now that I have 6 chlorines over here and only 1 over here, I should probably put a 6 right here. That gives me 6 chlorines. It also gives me 6 hydrogens. So my final step to balance the hydrogens, I need this to become a 6. There's already a 2 right here. So if I put a 3 in front, the 3 and the 2 multiply. That makes the hydrogen become 6, and the sulfur multiplies by 3 and becomes 3. And now you can see I've got 2, 6, 6, and 3, all balanced. Let me show you one more. I'm going to do number 36. It's a little tricky because it has parentheses. So here we go, number 36. I have aluminum, hydrogen, sulfur, and oxygen. Writing them in the same order. I have 1 aluminum, 2 hydrogen, 1 sulfur, and 4 oxygen. On this side, I have 2 aluminum, 2 hydrogen. Now sulfur, I actually have 3. That is because this 3 outside the parentheses distributes in, just like it would if it was a 3 in front of parentheses in math. So I have 3 sulfurs, and then the 3 multiplies by the subscript of the oxygen. So I actually have 12 oxygen. Let's balance the aluminums first. I have 2 over here and just 1 over here. So I can put a 2 in front of the aluminum. Now I want to work on the sulfur. So on this side I have 3, on this side I only have 1. So if I put a 3 right here, that gives me 3 sulfur. It also gives me now 3 times 2 is 6 hydrogen and 12 oxygen. So my oxygen and sulfur are both balanced. Now just to balance the hydrogen, I need to make this become 6. The best way to do that is to put a 3 right there. The only way to do that, actually. And we have a balanced equation. So hopefully that was a helpful demonstration. Good luck. Let me know if you have other questions.